All right, so now we're going to look at a quadratic inequality. And a quadratic inequality is the same solving process that you've seen, but we're going to use this notation that we've seen in the past to describe the answer. So the answer is an interval of solution, not just x equals 5. It's going to be between 5 and 3 or something like that. And it is the domain of an intersected region. Remember, we're graphing two graphs. They actually have an intersection, and we're going to graph what's between them. So if it is an and graph, remember that that is two parentheses. If it is open circles, which in this case will be dotted lines, remember that and is two less than symbols, meaning between. It could be two brackets if they are inclusive, or for a graph, a solid line, and that would have equal signs, double less than signs. These two things in math mean in between. If it is or, and you write it in set notation, it would have greater than symbols. But if you write it in interval notation, you would have to use a union. Notice that there are parentheses when there's no equal sign, but there's a bracket only on the number here. So if these were numbers, you would bracket them, but of course you cannot bracket an infinity sign. So let's take a look at what this looks like graphically from a previous chapter. We're going to focus mainly here on how to do this with transformations. I think it'll be a nice memory of how to do it, but it'll also be a way of seeing what's going on with these symbols up here. So imagine this were just a normal graph. Y is equal to x squared. If it were like that, the vertex of that graph would simply be at 0, 0, and we would graph 1, 1, 2, 4, negative 1, 1, negative 2, 4. So let's take a look at what that would look like, right? That would just be a dot here. 1 squared is 1, 2 squared is 4, and likewise with the negative values. So we just have to hit the pause button for a minute here and take a look at what this is going to mean. We have a negative, right? So try to remember what that's going to mean from the chapter just a couple of chapters ago, transformation chapter. That means that these positive values should have actually been negative, right? And then we need to make sure we remember from Algebra 1 what it means to graph a curve that does not have an equal sign. Well, if I don't have an equal sign, I just draw a dotted picture rather than a solid one. Okay, so we're going to draw a dotted parabola. And then they also want us to graph below. So we'll just kind of make a mental note that if, we're going to graph below this parabola, but I'd like to do that last part together. So this one, remember, there's no parentheses here. Remember my little way to remember that. No parentheses means no h. So this will have 0 for the h value and negative 2 for the k value. So when we graph that, we're going to graph it at 0, negative 2. We're going to go 1 squared is 1, negative 1 squared is 1, 2 from the vertex, and then up 4, and then negative 2 and up 4. And then we are going to draw a solid parabola. And we're going to think about now where the graphs will share intersection, because this one is graphed above. So if you ever have trouble with that, again, draw a little person on the graph, right? This is a greater than sign, so we would shade up here. This person, if I drew it on the graph here, right, would be less than, so it would be at his or her feet. So the question is, how do you figure that out? Well, what I like to do a lot of times, I'll actually label the places, right? It could be A, it could be B, it could be C. And then I just start with the blue one. Well, which of these is correct for below the blue line? That would be B and C, so cross this one out. And now which one is correct of these two, the ones that are left, which is correct that's above the green one? So that would be B. So the intersected region is right here. And so now we're going to use those indicators to describe this region. And remember, this is just like doing domain and range, right? So if you go back and do domain, and we use a vertical line to describe that domain, and I were to beep here, beep, we're beeping from here to here where the intersection is. And so that intersection is occurring, right, at negative 1 to 1, and it's between. That's what this means. See these double less than signs? Those mean between. So it's an interesting fact. Which one do we choose? Well, when one does not have an equal sign, that dotted line can never intersect that solid line. So if one of them is missing the equal sign, you have to use parentheses. So to wrap all this up, we're going to use parentheses to describe the answer. we're going to describe the answer of the domain of the intersected region. So beep, between -1 and 1. And we're just going to leave it like that, because that tells everyone reading it that the answer, the solution of this inequality and this inequality is between -1 and 1. This is not a point. This is this region using the domain language. You can also, I mean, it is equivalent to write this answer, right? But the question is the domain described by x's? So sometimes that notation just isn't the best, and this is the more upper level notation to use. All right, let's take a look at another example. So this one right here does have an h. Remember, when you do the vertex, h is always opposite when you actually graph it. So it says -3, but it's actually going to be +3. And then we're going to graph that. So we'll go to +3, 0. There is no stretch or compression or reflection. So 1 squared is 1, 2 squared is 4. Likewise with the negative values. Then for the next one, we have this one. This one has an h value, which will be represented in the vertex as 2, opposite h, and then 5. Please notice this one does have, like the other one did on the other problem, a negative reflection. So I think at this point we can probably hopefully do that all at once. So 2 and then 5 is the vertex. Instead of going 1 up 1, we're going to go down 1. And same thing with the -1. And then we'll go 2. Instead of going up 4, we'll go down 4. And then here we'll do the same thing. Okay, they're both solid. So I'm going to go ahead and graph the solid line for the green one. And if it confused you about those dots going over top of them, you might want to graph them as you go along, but I remember that they're right there. And don't just assume that it's going to be here. Let's see what happens, okay? So you can clearly see, and again, this lettering thing, kind of like making your own multiple choice question, it really helps. So I'm going to letter. I think we can clearly see the answer is probably either A, B, or C. So let's see if we can figure out where it is. Again, it does help. I know it's silly to just draw a little person right here. Their feet have to always intersect the parabola. So this one is less, so we're going to shade below. So that means that these two, right, we're going to shade below. This one is out. But this one's also below, notice, right? There's also another region down here, so maybe we can add a D there. So all of these regions are below the blue graph. And then if we draw a person here, remember, we can't draw a person down there because they can't stand on the parabola. So you just draw a little person right here on the parabola. Always have their feet there. This one is graphed greater than or above. So if we're going to graph above, right, then that means that we cannot have D. D would be out of the picture, and that would leave us with A and C. So our intersected regions would be here, all of this over here, and all of this over here. So the way we would describe that's the description of or. It's going away from itself as opposed to coming in on itself. And so we would do the domain thing again, right? We would be beeping here, beep, until there. Remember, okay, that this right here, you know, over in this area, this is -infinity. So we would go from -infinity, remember its domain, that point was 2. And then we're going to union that with the next part of the domain, which would start back right here, right? Nothing, so beep, nothing, and then beep, and that was at 4, and then goes to infinity. So from 4, right, not this point, but that point, to infinity. Infinities always get parentheses, but then the numbers, do you see how these both have equal signs? We have solid lines, so these would be brackets. And the only time you use a bracket is if both lines are solid.